In this video, we're looking at the relationships between the angle pairs that we discussed yesterday, transversals, which create those angle pairs, and as they relate to parallel lines specifically. So in the diagram here, we can see that we've got two parallel lines, and as I move one of the lines, you can see that the other one's going to move with it. And then we've got the transversal as well. And the transversal, if you'll recall, is a line that intersects two or more other lines at different points. So around this intersection point we have our four angles measured, and around that intersection point we have the four angles measured. And we're going to be highlighting specific pairs of angles, and you'll see over here the angles that we talked about yesterday. And we're going to be looking at how their measures are concerned. So in each case, I'm going to look at corresponding angles first. We know from yesterday that there are four pairs of corresponding angles present. Here I've got two of those corresponding angles marked. Look at the measurement of each of these angles. Here we've got an 86-degree angle. There we've got an 86-degree angle. And what I'm looking to determine is, are those angles, what is the relationship between their measures? And in this case, no matter where I move these lines to, the angles of course change as those lines move, the corresponding angles keep the same measure. And that leads us to what's known as the corresponding angles postulate. The corresponding angles postulate states, if two parallel lines are cut by a transversal, note this only applies to parallel lines, then the pairs of corresponding angles are congruent. If you need to, you can pause the video at this point to get that into your notes. All right, let's look at the next pair of angles that we have. We have the alternate interior angles. Alternate interiors, remember, interior tell us they lie between the two parallel lines. Alternate indicating that they lie on opposite sides of the transversal. Here we can see one pair of alternate interior angles highlighted in blue. And there again we're looking at their measures. And we can see that no matter where we move these lines to, 85 and 85, that those two angles, 93 and 93, keep the same measurement as well. So that leads into the alternate interior angles theorem. If two parallel lines, there again it only applies to parallel lines, are cut by a transversal, then the pairs of alternate interior angles are congruent. So we have corresponding angles that are congruent and alternate interior angles that are congruent. And if you need to, you can pause the video again to get that written down. All right, let's look at our next pair, alternate exterior angles. Alternate exteriors, you'll recall, are outside the two lines, in this case outside the two parallel lines, and on opposite sides of that transversal. So in this case we see a pair in red. We've got the 93-degree measure up here and a 93-degree angle there. Move the transversal, 70 and 70. Let's try moving our parallel line. We've got a 94 and a 94. So that leads into the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent, much like we have with corresponding angles and alternate interior angles. Here again, you can pause to get that into your notes as needed. Okay, the last pair of angles that we talked about yesterday were the consecutive interior angles. You'll recall by definition that consecutive interiors are also known as same side interiors. So the word interior tells us that these two angles lie between the lines, in this case between our two parallel lines, and on the same side of the transversal. And in this case we can see that these are not congruent like the other ones have been. An 89 and a 91. So what type of relationship do we see that would work with 89 and 91? What if I move this to 70 and 110? You should be seeing that these two angles, their measures have a sum of 180 degrees. And we have a special word for that we've learned previously, supplementary. So looking at the consecutive interior angles theorem, if two parallel lines are cut by a transversal, then pairs of consecutive interior angles are supplementary. So in this case, corresponding angles postulate tells us the corresponding angles are congruent. The alternate interior angles theorem tells us that the alternate interior angles are congruent, and the alternate exterior angles theorem tells us that alternate exterior angles are congruent if we have a transversal intersecting two parallel lines. So these only apply if the lines are parallel. Same is true for the consecutive interior angles theorem. The lines must be parallel, at which case the consecutive interior or same side interior angles will be supplementary. Now, the last theorem that you'll find in your notes is the perpendicular transversal theorem. And the perpendicular transversal theorem states that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. In other words, if I know that the angles here at the intersection point between this top line and our transversal, if those are all right angles, then because these two lines are parallel, these angles at this intersection point must also be right angles. So if the transversal is perpendicular to one of the two lines, and the lines are parallel, then it must be perpendicular to the other one. And that goes back to these relationships. If I think about the corresponding angles that we've looked at before, clicked on the wrong thing there. Because the corresponding angles are congruent, if this angle is a right angle, then the other corresponding angle in the other position must be a right angle based on the fact that the lines are parallel. So all of these go back to if two parallel lines are cut by a transversal, then these things are true. If the lines are not parallel, you can't make any type of statement related to the angle measures whatsoever. Okay, so let's look at the back of your notes and do some examples related to these particular theorems. All right, number 1, using the diagram, if the measure of angle 2 equals 110 degrees, what is the measure of each of the following angles? My advice, start by labeling everything in the diagram that you can first, and then go back and answer these questions. So in this case, we're told the measure of angle 2 is 110 degrees. Okay, a couple of things that I know. I know that vertical angles are congruent, so if angle 2 is 110 degrees, then the measure of angle 7 is 110 degrees as well. So these two will be congruent to one another. If I use corresponding angles that are also congruent, angle 2 and angle 6 are corresponding, so that's going to be 110 degrees as well. And vertical to that would be angle 3, which would also be 110 degrees. One thing to point out, I can make these conclusions because of the fact that these little triangles are here. And if you recall correctly, those little triangles indicate that the lines are parallel, which is why all of these corresponding angles must be the same measure. Now let's consider the other angles, the ones that are not 110 degrees. Grab another pen here, a different color. All right, so let's deal with a linear pair. Look at angle 4. I know that 4 and 2 are a linear pair, so they have to be supplementary, which means if that's 110 degrees, this one will be 70 degrees, so that it totals 180 together with angle 2's measure. Use your corresponding angles. Angle 5 will also be 70 degrees. And our vertical angles. Angle 1 is 70 degrees. And lastly, angle 8 is 70 degrees. So because those lines are parallel, we have all these 4 measurements in place. Now let's answer the questions. So part A, what's the measure of angle 8? 70 degrees. The measure of angle 1? 70 degrees. The measure of angle 3? 110 degrees. And the measure of angle 4? 70 degrees. So filling it into the diagram first is going to speed up this process considerably. All right, let's look at another example. This one's a little more algebraic. So here again, I see these little triangles, and that tells me the lines are parallel. Therefore, I can use the theorems from today. If those little triangles are missing, or if it's not stated that the lines are parallel, don't make any assumptions. All right, so I see a 72-degree angle here, and an angle marked x minus 8 degrees in that case. Now looking at them, I know from measurements alone that this 72-degree angle here is acute. I also know that this x minus 8 degree angle does not appear to be acute. Now, does that mean it can't be the same measure? No, but let's look at what's happening here. If I use vertical angles, this angle becomes 72 degrees. Now you should notice that that 72 degree angle and the x minus 8 degree angle are now consecutive interiors, or same side interiors. So from what we know in our theorems on the first page, if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Supplementary, recall, means that they have to total 180 degrees. So 72 plus x minus 8, adding the two angles together, equals 180 degrees. Okay, combine our like terms. 72 minus 8 gives us a positive 64. Subtract 64 on both sides, and we get x is 116. Now if we double check it, x minus 8 would be 116 minus 8, which is 108. So the question becomes, is 108 for this angle plus 72, does that equal 180? Yes, it does. So our answer is correct. And that's just the check over here on this side. You can check these to make sure that you're right. You don't have to, but it's a really wise idea if you do. All right, let's look at number 3 then. In number 3, we want to find the value of x. In this case, let's see, what do we see? I don't see any particular angle pairs that are terribly useful. I can see that this 70 degree angle and this large angle all the way across, that giant obtuse angle, that those are consecutive interiors. But there are other angle pairs present. First of all, let's note we've got parallel lines again. That's what the little triangles are telling us. So what other types might I see? Do I see corresponding angles? No, because corresponding would be up here, and that doesn't get me much too far. I could extend the line, make these longer, and then mark that 70 degree angle up here. That wouldn't be wrong. Let's see, so that could be a corresponding alternate interior. That's 70. And this angle would be alternate interior, so this one would be 70 degrees. You'll note that that's the vertical angle to the corresponding angle as well. Now, does that tell us anything? If this angle is 70 degrees and these two are x and x minus 20, what do we know about all three of those angles together? Well, given the fact that they all lie on that one line, that tells me that the three angles, when added together, have to total 180 degrees. So 70 plus x minus 20 must total 180. Combine your like terms. X plus x is going to give us 2x. 70 minus 20 is 50. Subtract 50 on both sides, and divide by 2 on both sides. So x becomes 65. Now let's check it, make sure we're right. If x is 65, then I have 70 plus 65 plus 65 minus 20 is 45. Does this total 180 for our check? So let's see, 5 plus 5 is 10. If I carry a 1, 7, 8, 14, 18. So yes, it does. Which means our answer for x is correct. Now you want to be careful on algebraic problems to make sure that the value of x is what's actually being asked for. Sometimes it'll ask you for, instead of the value of x, it'll ask you to find the measure of a specific angle, where you just substitute it back in. But ultimately, those are the steps that we're going to be taking. You now have a worksheet that you'll need to get and complete.